Hi, welcome back to the AI 900 Azure AI Fundamentals prep class. We're now on part 2. If you looked at the previous video, part 1 was quite long. However, the other 4 parts should be much shorter. That's the biggest sort of overview module. So, my name is Michelle Sanford. I am a developer engagement lead at Microsoft. Connect me on LinkedIn if you can. I also make notes for all of the exams that I do on my GitHub portfolio. So if you go there, you can find the notes that I've made for each of the exams. Some of them are more comprehensive than others, but I have passed all the exams I have taken to date, so you can rely on those notes. I'm not all, I mean, you should follow the learning path, of course, but I hope you find those notes useful. If you do, give me a little star on there. Okay, welcome to part 2, where we're going to talk about machine learning. As in part 1, I make these little mind maps, which kind of help me map out the key concepts that I want to remember. And when I say key concepts, I kind of split out the module into the key components, and then I list sort of examples as to what those things look like in real life. So if you're going to apply the principles, apply the concepts, what those models look like, or what examples of that machine learning looks like in the real world. I think it really helps me to cement the knowledge of what we can use what we can use this stuff for, and how we can use it, and the things that we should take into consideration when we are setting it up. You should make your own notes as you go through the learning paths, as you look at my GitHub. If you have access to the practice test, you should make your own notes, and like maybe they'll be different than mine, but maybe they'll be the same. I hope you find mine useful anyway. Here we go. So in here, we are going to cover these concepts. We're going to talk about machine learning. We're going to talk about regression, classification, and clustering. And as I've said, generally for this exam, I talk about what each of those things looks like in the real world, because generally the questions for the fundamentals exam are around, what is this an example of? If you saw this, what would it be? If you wanted to solve this problem, what would you use? And so knowing what things look like in real life is really what the exam is all about. We're also going to talk about, for Azure Machine Learning, what is Azure Machine Learning, what's automated machine learning, and what's the Azure Machine Learning Designer. So machine learning is creating predictive models by finding relationships in data. And you should recognize this little GIF here. It's the classification image generally. There we go. So that little GIF was in the machine learning path. There we go. Okay, so regression models. Regression is a form of machine learning that's used to predict a numeric label based on an item's features. So, for example, a car sales company might use the characteristics of a car, such as engine size, number of seats, mileage, and so on, to predict its likely selling price. And in this case, the characteristics of the car are the features, and the selling price is the label. So regression is an example of the supervised machine learning technique, in which you train a model using data that includes both features and known values for that label, so that the model learns to fit the feature combinations to the label. And then after the training has been completed, you can use the trained model to predict labels for new items for which the label is unknown. So one of the things they will often ask you in questions is this an example of a supervised machine learning technique, or an unsupervised one. So it is important to sort of get that understood as well, the difference between those things and what that means. So here's some examples, and I have them, I think, in that first mind map that I drew. So predicting online sales volume for the next financial quarter. So if they say regression and they say predicting, often like you can link those keywords together in your mind. Also, if they have the word historical in there, it's often talking about a regression model. Not always, and I have some examples where they're kind of a little bit tricky about that, but generally, if you're just looking for keyword matching, predicting, historical, regression, all of those things go together. So predict house prices based on location, number of rooms, etc. Predict if a patient needs to be admitted to a hospital based on previous health records and recent medical test results. Forecasting stock market values based on macroeconomic changes. Predict ice cream sales based on weather forecasts. Predict the number of likes on a social media post. So generally you see, if we're talking about regression, they're going to be talking about prediction, or they might have the word historical data in there. Historical data to predict or forecast new values. So classification is a supervised machine learning technique, and it will predict which category or class an item belongs to. So, for example, a health clinic might want to use the characteristics of a patient, such as age, weight, blood pressure, and so on, to predict whether a patient is at risk of diabetes. In this case, the characteristics of the patient are the features, and the label is a classification of either 0 or 1, representing non-diabetic or diabetic. So it's an example of a supervised machine learning technique in which you train a model using data that includes both the features and the known values of the label, so that the model learns to fit the feature combinations to the label. Then after training has been completed, you can use the trained model to predict labels for new items for which the label is unknown. So all of that sounds just like blah, blah in my mind until you start to, think about what does that look like in real life, which is why I'm all about the examples. So classification, check whether newly arrived emails contain spam, yes or no. Analyzing X-ray images to detect whether a person has pneumonia, yes or no. Is the object in the image a hot dog, yes or no? Is it A or is it B? But it can also be what type of bird is in the picture. So you could also have, penguin, eagle, pigeon. That's multi-class classification. Processing tweets to categorize them as positive or negative. Positive, negative. Approve or reject a customer for credit. So classification is used to make predictions in a non-continuous form. So learning from labeled data to classify new observations. Model trained on the labeled sets of X-ray images of various patients can analyze new images and classify in a binary way whether the person does or does not have pneumonia. The supervised learning model is one that learns from labeled data to predict the class or the category of the label from new or unlabeled data. So, you would previously have uploaded a whole bunch of X-ray scans of patients that have pneumonia, and then you would have uploaded a whole bunch of X-ray scans of patients that do not have pneumonia, and you would have labeled them all each as has it, does not have it. And then the model trained on those, when presented with an X-ray that it has never seen before, should be able to compare it to that previous stuff in its mind. It doesn't have a mind in its model, but it should know whether that is more like that or like that. So do they have pneumonia or do they not have pneumonia? And they are more accurate than humans because of course humans get tired squinting at very small detailed changes in scans, and after a while it all starts to get blurry, especially if they're working super long shifts, as our medical professions have to. So yeah, having a machine that can scan or look and look for those small detail changes and then say it is this or it is that is a lot more reliable method for doing that. So there are like a bunch of metrics around these models as well. So in the classification model, it's going to talk about recall, so correct results. It's going to talk about precision. These are true results over positive results. And you need to be able to, in some of the questions, it will ask you what kind of metrics, what is a good metric, what will tell you whether this is a good model or a model that has been trained well, that kind of thing. So yes, it's worth recalling, it's worth looking up and memorizing what are the most commonly used metrics for each model. That is definitely something you will see in the exam. Yeah. Okay, and then the third model is clustering. So this will group similar items into clusters based on their features. So for example, a researcher might take measurements of penguins and then group them based on similarities in their proportions. Well, I guess if you look at this image, like there are some penguins here that have orange beaks, some that have black beaks, some that have white heads, some that have black heads, some that have spots in their heads. And it can group them like that, and maybe those are the different let's say different races of penguins, but not really races, breeds, tribes. Anyway, different. That's what it would train them on. So clustering is an example of unsupervised machine learning, in which you train a model to separate items into clusters based purely on their characteristics or features. Grouping together online shoppers with similar traits for targeted marketing, group documents with similar topics or sentiment. Clustering analysis analyzes data to find similarities in data points and groups them together using unlabeled data, and can explore unexpected correlations. So k-means is one of the metrics that it has in there. And it's unsupervised learning. So remember that the data is not labeled, and the algorithm itself will aim to determine the structure of the data. Okay, Azure Machine Learning is a cloud-based platform for machine learning. And that's what it looks like. And then we have automated machine learning, which takes the hard work out of machine learning. So you supply the data and the desired model type and let Azure Machine Learning find the best model. People often talk about black boxes in machine learning, and explainer models is one of the concepts that is pretty interesting, because people have the impression that you just throw all your data into the machine, into the cloud, and then it will make the decisions for you, and you have no way to know how it has made those decisions based on what choices. There's a lack of the responsible AI principle around transparency. However, that really is not the case. There is definitely a lot of explainer models which will help interpret how the machine learning has come to its decision and what it has done to make its choices. But also there is a little box that you can tick, which will, what is it called? It will explain, it will give you some transparency, and it will explain how it has done it for you. There's a specific name for that. We'll come back to that later. I've definitely got it in here somewhere. Oh, there it is. It's right in front of me. So in order to ensure automated machine learning follows the transparency principle of responsible AI, you should configure the enable explain best model option. This explanation allows you to understand why the model was selected and how the model works, and it enables you to meet regulatory requirements and provide transparency to users. So tick that box basically, and then you will have your explanations. Tabular and file data sets are the data source types supported in Azure Auto Machine Learning. So CSV, TSV, Parquet, JSON, or SQL. Automated machine learning can train and tune a classification model, and automated machine learning can train and tune a regression model. So it's pretty flexible, pretty cool. And then there's also this Azure Machine Learning Designer, which is a visual tool for creating machine learning pipelines. In the exam, you see those, see the words inside of the boxes. They will often have a few of those words at the bottom of the screen and say, drag the correct ones into the correct boxes. From the shape of this flowchart, you should be able to tell what goes where and in what case. So you'll see these in the learning paths. That's like a really good way to sort of get a feel for what it's going to be like. If you have access to the practice exam, I do think the practice exams are really, really good. And they give you a good feel for how this all works as well. But otherwise, yeah, I guess just reading the machine learning path explains it in really good detail, but you definitely need to know this for the exam. I just wonder, is that the same? Yeah, so this is not those are not the same models that we have there. This is a two-class logistic regression model. And here we are splitting the data. So we have like a big data set, and we're going to use half and half, or maybe not half and half, maybe slightly more for one than the other, probably slightly more to train the model. And then we'll use the rest of the rows for scoring the model. So this is just to check that it's working as expected. And then we will evaluate the model. And then the next one, in here, normalizing the data, that's like cleaning it up, getting rid of some of those empty cells, empty rows. We're going to split the data. We're going to train the model on one part. We're going to score the model with the bit that's left, and then we're going to evaluate. But that's all, yeah, that all looks pretty much the same style. Let's do some practice questions, shall we? So, predicting the online sales volume for the next financial quarter is an example of what machine learning scenario? Predicting is regression, for sure. Where I keep talking about keywords, prediction, forecasting, regression, those words always go the same, always go together. Now, maybe not always. They might try and trick you. Like in the previous module, I showed you an example of where they try and use it, but then the question ends up talking about something else. Watch for that. But generally, predicting online sales is an example of regression. In a regression machine learning scenario, you predict a numeric value, typically in continuous form. So in this, you can use machine learning to predict the online sales volume for the next financial quarter by using historical sales volume data and various factors such as holiday seasons, confirmed sales, orders, and so on. Classification would be used to make predictions in a non-continuous form. So that involves learning from labeled data to classify new observations, e.g. to check whether newly arrived email messages are spam or not. And clustering analyzes data to find similarities in data points and group them together using unlabeled data to learn about purchasing habits of e-commerce clients. Something is a machine learning method that predicts, determines the category, type, class of a data item. Okay, so here it's used the word, yes, category, type, or class. This is going to be classification for sure. So classification is a supervised learning method in which the model learns from labeled data to predict the class or category of the label for new unlabeled input. Classification algorithms may be binary, whether it's A or B, or whether an email message is spam or not, or multi-class, pigeon, eagle, or penguin, for example. And clustering is a method by which the machine learning groups data points with similar characteristics. People who bought this book will also buy this book, and probably this one and this one, not that one. So, yes, what do they look like? Think of that. Forecasting, regression. Forecasting, regression. Forecasting stock market index values based on macroeconomic changes is an example of what machine learning scenario. It's regression. In a regression machine learning scenario, you predict a numeric value, typically in continuous form. Oh, actually, I'm just like reading out the definitions of each of those things to you. But yeah, if you go back to the original, I go all the way back to my original little mind map, and you will see. There we go. Then you will see it really helps make clear what each of the ones look like if you sort of put them like that. Regression looks like this. These are examples of what regression looks like in the real world. These are examples of the metrics. So those are actually metrics for regression, MAE, RMSE, COD. You want to look those up and see what those mean. You want to remember that that's a supervised machine learning type. For classification, those are the metrics: precision, recall, and F-score. And for clustering, I have not put the metrics in there, have I? So that's something you definitely want to look up. What are the metrics for clustering? Is it supervised or unsupervised? So this one says supervised. This one says supervised. This one is definitely unsupervised, but I haven't put that in a bold thing. And I haven't put what the metrics are in here. You need to remember that. And you also need those pipeline diagrams, and you need to remember what order the things go in so that you can sort of drag and drop them into that picture. And then that is it for this module. So I will see you in the next part.